This is our second example for the paired sample Wilcoxon signed rank test. Let's take a look at the question. An athletics coach wishes to test the value to athletes of an intensive period of weight training, and so selects 12 400-metre runners from the region and records their time in seconds to complete the distance. Then they undergo the programme of weight training and have their time in seconds for 400 metres measured again. The table below summarises the results. Use a Wilcoxon signed rank test at the 5% significance level to investigate the hypothesis that the training programme will significantly improve the athlete's time for the 400 metres. We know this is a paired sample Wilcoxon test because we have pairs of data for each athlete, a before and an after time. So when we are doing a hypothesis test, we need 6 steps. We must state the hypotheses, if it is one or two tailed, and the significance level. We must calculate the test statistic, find the critical region, and compare and conclude. So let's start with our hypotheses. We must have a null and an alternative hypothesis called H0 and H1, and for the paired sample Wilcoxon signed rank test, that should say, we have e to d. So remember that weird n that's elongated on the right is the Greek letter eta, which represents the population average, and therefore e to d is the population average difference. We are always assuming that there is no difference between the pairs of data, so that equals 0 for our null hypothesis. Then our alternative hypothesis also uses e to d, but this time we need to read the question to find out what we're being asked to investigate. So in this question we're looking if the training programme will improve the athlete's time. So let's think about that before and after and that difference that's going to create. If the training programme will improve the time, that means we are expecting their time after the programme to be less than that before. We're expecting them to be quicker because it's made an improvement. So my inequality here is before is greater than after. Rearranging that equation, I will say before take away after is greater than 0. And therefore my H1 is e to d is greater than 0, using the subtraction before take away after. I can also have e to d is less than 0 if I do after take away before. So, is this one or two tailed, and what is the significance level? Thinking about our hypotheses, specifically our alternative hypothesis, we know that e to d is greater than 0, so this is a one-tailed test. We're just looking at the upper tail, and in the question it states that we are using a 5% significance level. So now we move on to step number 4, which is calculating the test statistic, and this is the part of the question that is worth the most marks. So to calculate our test statistic for a paired sample Wilcoxon, we have 4 steps. The first one is to calculate the signed difference for each pair of data. So my alternative hypothesis for this one stated that I was going to do before, take away, after. That's the difference I'm looking for. So that's what I'm going to do for each athlete. So I'm going to do 51.0 take away 50.6, and that's going to give me plus 0.4, and I'm going to do that for each one. You might want to pause the video here, work out the differences, and check that you agree with my calculations. So I get negative 0.6, plus positive 0.6, positive 1, 0, positive 1.3, negative 1.1, positive 0.7, positive 2.1, positive 0.1, positive 2.3, and positive 1.7. So step 2 is where I use my ranking, and this is from the closest to 0 to the furthest away. If I have a difference of 0, as I do for athlete E in this example, unfortunately I can't use that to help me prove or disprove my hypotheses. So I have to discount athlete E from my data, so I'm just going to put an X next to him or her. So again, you might want to pause the video here to see if you can rank this data correctly. So starting with closest to 0, I have athlete J, which is 0.1 away. I then have athlete A, who is 0.4 away, so they get rank 2. Then B and C were both 0.6 away, although in opposite directions, so they are going to take up ranks 3 and 4. And to make that fair, I'm going to find the median of those, which is 3.5, and they are both going to have a rank 3.5. Then athlete H has a difference of 0.7, and obviously because I've used up ranks 3 and 4 for B and C, they have to have rank 5. Rank 6 goes to athlete D, then athlete G, athlete F, L, I, and K. Then the third step is I need to calculate the total of the positive and the negative ranks. Personally, I choose to highlight or circle the positive ranks just so I can quickly and easily identify the difference between the two. So as you can see, I've just circled all of those athletes who have a positive rank, and I now know I need to add up 2, 3.5, 6, 8, 5, 10, 1, 11 and 9, which gives me 55.5. Then for my negative ranks, I rank whatever's left over, so 3.5 and 7 to give me 10.5. My final step then is to find the test statistic, which is the smallest rank total, and for this one it is 10.5. Step number 5 then is identifying the critical region. So for the critical region I need to find my value of n. In this question I had 12 runners, 12 pairs of data. However, I couldn't use athlete E because there was no improvement, or what's the opposite of improvement? Unimprovement? Because they had a difference of 0, so I had to change that to n is 11. That's important when you're finding your critical value. I then need to turn to my critical value tables, which are table 10, and it's the penultimate table in your formula booklet. This is a one-tailed test at the 5% level of significance, and we've established that n is 11, so my critical value for this one is 14. And then my critical region is anything that is less than or equal to 14. Even though this is a greater than H1 question, remember that the table only gives the lower tail values, so I still do less than or equal to. Finally then, step 6 is my compare and conclude. So I need to draw my line from 0 to infinity. I need to identify my critical region on that graph. So there's my critical value at 14, and my critical region is that red section underneath. Then I need to compare that with my test statistic, which was 10.5. And because it lies in that critical region, I can say that I reject H0. So to conclude that in context, I need to remind myself of what I'm being actually asked to do in the question. So if we just bring that sentence back up, it says, use a Wilcoxon signed rank test at the 5% level of significance to investigate the hypothesis that the training program will significantly improve the athlete's time for the 400 metres. Remember, H0 is that there is no difference at all. They're both pretty much the same thing, and we are rejecting that. Therefore, we are saying, yes, it does seem that there is some improvement in the athlete's time, so I can say that we have enough evidence for that. So therefore, there is significant evidence to suggest that the claim that the training program will significantly improve the athlete's time for the 400 metres is correct.